Section 8.5, we're going to talk about trapezoids and kites. But first of all, take a minute right here to write down everything you might be able to say about a quadrilateral. Like, what do we know? Anything at all about any quadrilateral? Well, you might have started out with four-sided figure, but do you also remember that the sum of the interior angles is always going to be 360 degrees, and the sum of the exterior angles will always be 360 degrees? Did you maybe write down anything about that fact that it could be a parallelogram if both pairs of opposite sides are parallel or congruent, or both pairs of opposite angles are congruent, or the diagonals are bisecting each other, or just one pair of opposite sides are both parallel and congruent? That makes it, that quadrilateral, a parallelogram. And if it's a parallelogram, all those things are true. It could also be a special parallelogram, a rhombus, a rectangle, or a square. And again, rhombus would have four congruent sides, rectangle would have four congruent angles, which makes them right angles, and a square as both. So today we're going to talk about things that are quadrilaterals and they are not parallelograms. So we're going to understand the properties of trapezoids, including isosceles, and the properties of kites. So, trapezoid has exactly one pair of parallel sides. If it had two pairs, okay, then it would be called a parallelogram. If it does have two pairs, it is called a parallelogram. So, the features of an isosceles trapezoid are much more interesting, and so a lot of the trapezoids will be isosceles. So if the legs of the trapezoid are congruent, then the trapezoid is an isosceles trapezoid. So here is a leg, and here is a leg. The bases are the parallel sides. So if they are congruent, then it's an isosceles trapezoid. And there are some certain features of isosceles trapezoids. So a trapezoid is going to be isosceles if and only if the base angles are congruent. So in other words, that's a way to prove it's an isosceles trapezoid, besides the fact that you have this pair, these legs are congruent, and you can see that it's a trapezoid because you have exactly one pair of parallel sides. So if you're not given those things, and the base angles are congruent, then you know it's isosceles. So if your base angles that are connected to your base are congruent, then it is isosceles. So it's kind of like on the same wavelength of sort of an isosceles triangle. Remember, the base angles are congruent in an isosceles triangle. And so here is our base, and so the angles opposite the bases are congruent. So another way to prove a trapezoid is isosceles is if and only if the diagonals are congruent. So that means that BD will be congruent to AC. So these diagonals will be congruent. So, in trapezoids, we have midsegments. The midsegment of any trapezoid, not just isosceles, of any trapezoid, is parallel to each base. So this midsegment right here, you can see, is parallel to the other two bases, to each base. And as you might expect, that it is going to be the average of the other two bases. So in other words, it's not the same value as AD or BC, but if you take the average of the bases, that's what the length of the midsegment is. So you take the two bases, add them up, divide by 2. Pretty simple. So let's try some problems. It says ABCD is a trapezoid and EF is its midsegment. So if it's a midsegment, remember these two pieces will be equal because it's formed from the midpoints of each side, of each of those legs. Okay, we also know because it's a trapezoid that these two bases are parallel and the midsegment is going to be parallel to it. Remember, the midsegment is the average of the bases. So that means that AD plus BC divided by 2 equals the midsegment EF. So now we can just fill in the pieces we know. So AD we don't know, so let's call that X. So we have X plus BC, which is 8, divided by 2 equals 14. Now some of you could probably just do this in your head intuitively, and that's certainly fine. But now we're going to multiply each side by 2, which gives us X plus 8 equals 28. Now I'm going to subtract 8, and I get X equals 20. So AD is 20 units. Okay, here's another one. ABCD is a trapezoid. Find the measure of the remaining angles. Well, remember, it's a trapezoid, and so we can see right here that the base angles are congruent. So that means these other base angles are also congruent. And we know the sum has to be 360 degrees. So we know that 2 times 51 plus 2 times the angle we don't know, we'll call it X, has to equal 360 degrees. So now when I subtract 102 from each side, I get 2x equals 258. Now I divide and I get x equals 129 degrees. So the measure of angle B equals 129 degrees, and the measure of angle C equals 129 degrees. Okay, so what if we have coordinates? It says using the given coordinates, show that ORST is a trapezoid. Well, how will I show that it's a trapezoid? Well, I am going to have to find the slopes. Because if it's a trapezoid, the slopes should be parallel. And what you really should do is find the slope of all 4 sides to make sure it's not a parallelogram. I think it's probably obvious by looking at the slopes here, and you could actually count the slopes for this rather than, you could use y2 minus y1 over x2 minus x1, but because it's already graphed, we can see the slope of RS is equal to 1/2 because we're going up 1 over 2. Okay? So that's 1/2. Now we can do the slope of OT, and the slope of OT is going up 2 over 4, so 2 over 4, which is also equal to 1/2. So up 2 over 4, that slope is also 1/2. So what we found so far is that RS is parallel to OT, which makes it a trapezoid as long as the slope of RO is not parallel to the slope of ST, and the slope of RO is undefined, and the slope of ST is -1. So they are not parallel to each other, but RS and OT are. So that is enough to show that it is in fact a trapezoid. So we have just shown that it's a trapezoid because these two sides had the same slope and are parallel. So let's look at kites. And this is just a summary of what we said about isosceles trapezoids. But let's look at kites. So a kite is a quadrilateral with 2 pairs of consecutive sides that are congruent, but opposite sides are not congruent. So 2 pairs of consecutive sides that are congruent. So here's a consecutive side. Here's one, and here's the other right here. Okay, so two pairs of consecutive sides are congruent, but opposite sides are not congruent. So what that means is when you look opposite right here, opposite sides are not congruent. That is the definition of a kite. So how do we prove it? Well, a quadrilateral is a kite. If the quadrilateral is a kite, then the diagonals are going to be perpendicular. And one pair of opposite angles are going to be congruent. And that pair of opposite angles are between the non-congruent sides. I mean, it's usually obvious, I see from the picture, which ones are not congruent and which ones are, but that's how you can tell for sure because the pictures, the diagrams aren't always accurate. So kites, again, have perpendicular diagonals and one pair of opposite angles congruent. So again, this is kind of just a summary of kites that we've talked about already, just all together. So let's use the properties of kites to solve and find the value of x. So we see that we have two pairs of consecutive sides congruent. So it's a kite. So that means these angles between the non-congruent sides will be congruent. So I know that the sum has to be 360. So when I take 360 and I subtract 124 and I subtract 80, that leaves me 156 degrees left for two angles. So I have to divide that by 2, and each angle is 78 degrees. So x is 78 degrees. So here's a little bit more involved problem here, where we're solving for multiple things. It tells us it's a kite. We're going to solve for x, y, z. Notice we have the congruent angles marked. Remember, some of the features of the kite is we have consecutive sides are not consecutive sides that are congruent. So consecutive sides congruent, we know that the diagonals are perpendicular right here, and we know the opposite angles are congruent between the non-congruent sides. So I've marked all those things that we know. Well, right now, if I try to set up this side and this side, I have two unknowns. So I'm going to start with this side equal to this side. So I'm going to set 3x minus 6 equal to x plus 2. Now as I move things around, I'm going to get 2x equals, when I subtract x from each side and I move the other values over, I would get 2x equals 8, so x equals 4. So there's one of the values. I have found my x. Now that I know my x is 4, I can put it in over here. 4 plus 10 equals 14. So that side is 14, so y is equal to 14 units. So now I need to find z. Well, I know that x is 4, so I know this would be 4 plus 2, or 6. So now, remember, this is a right triangle right here. So this right here is a right triangle, so I can use the Pythagorean theorem to find z. So now I know that 3 squared plus z squared equals 6 squared. So z squared is equal to 36 minus 9, or 25. So z equals 5 units. So we found all the values. And we worked with some of the properties of kites and earlier